4.4, with matrices, we're going to talk about the identity matrix. The identity matrix is going to have ones in the diagonal and zeros everywhere else. So doesn't matter 2 by 2, 3 by 3, 4 by 4, whatever it is, the identity matrix will always have ones in the diagonal and zeros everywhere else. The inverse matrix we use so if I called a matrix A, it doesn't matter what my matrix is, I would say the inverse is this A to the -1, and this little -1 means inverse. That tells me the inverse to the matrix. When I multiply a matrix and its inverse, and when I multiply an inverse, it always goes first. When I multiply a matrix and the inverse, this is what it would look like. A -1, A, because the inverse always goes in front. I would get the identity, meaning I would get something that looks like ones in the diagonals and 0 everywhere else. If you're going to find an inverse by hand, and we can do this for a 2 by 2, it has a formula. It's 1 over the absolute value of the determinant of A. It's not an absolute value, it's determinant. The determinant of A times, these are interchanged, and these are opposite signs. And that's how you find by hand the inverse. So here, if I have the matrix 3, 2, and 2, 4, and you're just asked to find the inverse, what would be the matrix that I multiply to this to get the identity? I would do 1 over the determinant. Now, determinant is what we just did in the last one that says diagonal subtract diagonal. And then I interchange my diagonal, so 4, 3, and then I switch my signs, -2, -2. So that would be 1/8. And then when I distribute, that would be 1/2, -1/4, -1/4, and 3/8. This is the inverse of my original. And if I multiplied these two, I would get the identity. You will be asked to find the inverse by hand on a 2 by 2, where you do 1 over the determinant times the switch the columns, or switch the diagonal, and switch the signs of the other diagonal. If you're asked to do a 3 by 3, we use the calculator. So here's an example of a 3 by 3. 3 by 3 matrix, 0, 1, negative 1, 2, 0, negative 1, negative 1, 3, negative 3. So if I call this matrix A, I want to know what is matrix inverse. All right. So in our calculator, under matrix, we're going to edit. We're going to input our original matrix, 3 by 3. Put in the data points, 0, 1, negative 1, 2, 0, negative 1, negative 1, 3, negative 3. And then under matrix, math, oh, I'm sorry, that's not true. We got to clear it out. We got to go to our home screen. We're going to recall our matrix, second matrix. And then the matrix button that we use has this x to the minus 1. That's what we want to use. What is the inverse of our matrix? And there it is. The inverse of the matrix is 3, 0, negative 1, 7, negative 1, negative 2, 6, negative 1, negative 2. All right. Now, we could check this. If I check this, the inverse times the original will give me 1s in the diagonal and 0s everywhere else, or the identity. So I can recall the matrix inverse and multiply it to the original matrix A, and there it is. Inverse and regular gives me the identity. Put in the identity, just hit A inverse, and that gives me the inverse. And if I multiply them, I get my identity. All right, when you're asked to solve, for example, some matrix A equals some matrix AX, because X is a variable. AX equals some matrix B. Generally, you would go, oh, I divide. Well, in matrices, you can't divide. So what we use is we use the inverse. So instead of saying divide by A, what I would do is I would multiply by the inverse. Because an A and an A inverse gives me my identity, leaving just the X. And then this I get to punch in my calculator. So let's apply it to an actual problem here. Here I have the matrix 1, negative 2, 4, negative 7. And I'm going to multiply it to x, and it's going to equal 7, 2, negative 1, and 9. So what I want to do is I want to call this matrix A. I want to call this matrix B. So in my calculator, I'm going to put A inverse B. So go to the calculator. Go to edit. 2 by 2. Data points. Edit into matrix B. 2 by 2. Data points. Now on your home screen is where you're actually going to do A inverse B. Recall A, put in inverse, times recall B. A inverse B. There's our solution. Negative 51, 4, negative 29, and 1. Okay, if you're given more information, let's say 1, -2, 4, -7, x. Let's go, actually I'm going to put this on a new piece of paper. 1, 4, -2, -7, x plus 3, 0, -1, 5 equals. So now I have more data. I'm still solving for x. I'm still solving because there's an equal sign, and I always want my variable. Well, I solve it exactly as I would anything else. I would subtract this matrix so that I just have my one matrix, x, is equal to whatever that comes out to be subtracted. So 7 minus 3, 2 minus 0, -1 minus a -1, 9 minus 5, and now I have an A and a B, so that I do A inverse B. It's done the exact same way, because we know adding and subtracting, all they have to do is be the same dimension, and they're going to be in order to solve. So that's going to be 4.4.